In section 2.4, we're using postulates and diagrams. We're going to have just a series of postulates that we're going to talk about today, and we're going to talk about things that we can assume from pictures and talking about drawing diagrams today. So this is a list of all of the postulates we're going to look at. These numbers, again, don't really matter, but you can use them to abbreviate today so you're not always writing out everything. They're about points, lines, and planes, and I just kind of want to read through them and talk about them a little bit. Postulate 5 says, through any 2 points, there exists exactly one line. Do something for me. Hold up both your fists and picture your fists as 2 points. And if you think about it, no matter where you move your fist, there's only one line that you could make that would go through both of those points, or both your fists. And postulate 6 is kind of the reverse of that, that a line contains at least 2 points. For postulate 7, if 2 lines intersect, then their intersection is exactly 1 point. And we can see that pretty easily here. If 2 lines intersect means 2 lines cross. Their intersection is exactly 1 point. Well, yeah, anytime 2 lines cross, they'll cross at just exactly 1 point. In postulate 8, through any 3 non-collinear points, there exists exactly one plane. First of all, non-collinear means not together on a line. So they're not on the same line is what they're saying there. So through any 3 non-collinear points, there exists exactly one plane. Remember that a plane is a flat surface. And what I want you to do is take a look in whatever room you're sitting in right now and look at the corners of the room. You're going to have 8 corners. Use those as your points and pick any 3 corners in the room right now. And you'll find that there's only one wall that has those 3 points. And all you need is 3 points. So again, pick 3 corners of the room. And it'll have to be a certain wall, or maybe the ceiling or the floor, that has those 3 points. But 3 points is always enough to determine one single plane, or in this case, one wall or floor or ceiling. Postulate 9 is kind of the reverse of that. A plane contains at least 3 non-collinear points. Postulate 10 says, if 2 points lie in a plane, so right now, look up at your wall and pick 2 points, and realize that if you connected those 2 points with a line, the line containing them would also be in that plane. So if 2 points are on a plane or on a wall, then the line containing them or going through them is also in that plane or on that wall. Postulate 11, if 2 planes intersect, then their intersection is a line. Again, in the room you're sitting in, look at 2 walls that intersect. And again, by walls, it could be floor or ceiling as well. But pick 2 walls, or the floor in a wall, or ceiling in a wall, and check out where they intersect, and it's always going to be a line, either a line along the ceiling, along the floor, or straight up and down. We're going to look at examples of those today. Again, you can use these numbers to abbreviate, but you don't need to memorize those. First thing I want to do is identify the postulate illustrated. So you see if this picture, then this picture. Well, it looks like we have 2 lines here. And in the then, or conclusion picture, we have this very identified point here. Well, it looks like 2 lines are crossing, and 2 lines are crossing, and they really want you to focus on that point. That would be the one we sketched here, postulate 7. If 2 lines intersect, then their intersection is exactly 1 point, postulate 7. So again, I said you could abbreviate today. So on your homework, if they say which postulate, you can just write the number, postulate 7. What are we illustrating here? If this picture, then this picture. Well, each of these are represented like flat surfaces, right? So these are planes. We have the one in white and one in gray. So we have 2 planes that are crossing. And then in this picture, we have this red line identifying. Well, 2 planes are intersecting, and their intersection is the line where they meet. Which postulate said that? How about postulate 11? If 2 planes intersect or cross, then their intersection is a line. That's what we're illustrating here. Postulate 11. If 2 planes intersect, their intersection is a line. So one example of what you're looking at today. Another example might be take a look at a picture and identify examples of certain postulates. So here I need to do an example of postulate 5, 6, 8, 9, and 10 from this picture. Notice that this is called plane P, or you can always name with 3 letters, so plane A, B, C. We have a line on this plane with going through points A and B. And we have point C randomly on that plane. So let's see what postulate 5 said. I need an example of it. Through any 2 points, there exists exactly one line. Through any 2 points, there exists exactly one line. So I'm going to say through what 2 points does there exist exactly one line? How about through points A and B? There exists one line. And only one line. And the name of that line would be line AB. So postulate 5 said through any line there exists, through any 2 points there exists exactly one line. So through these points A and B there exists exactly one line, line AB. Postulate 6. Postulate 6 says a line contains at least 2 points. A line contains at least 2 points. So I need to find a line that has at least 2 points. And I could say line AB contains, and I'm going to list those 2 points because I have to say it contains at least 2 points. It contains points A and B. There we go, I listed those points. I did postulate 5 and 6, and I have to do 8, 9, and 10. What does postulate 8 say? Through any 3 non-collinear, not in a line, through any 3 non-collinear points, there exists exactly one plane. So I have to name 3 non-collinear points and give the plane that goes through them. Through, and it said non-collinear points, so I have to make sure that they're not all in one straight line. Through non-collinear points, and said 3 of them, so I have to list A, B, and C, and they are not all in the same line. And it said there exists exactly one plane, right? So there exists plane, and I'm going to name this with that capital letter P that I have there. So I named 3 non-collinear points and the plane that exists through them. Alright, postulate 9 would be next. What does that say? Postulate 9 says a plane contains at least 3 non-collinear points. So I have to name a plane. And here I can call it again plane P. It's kind of the reverse of the one I just did. Contains at least 3 non-collinear points. I believe it said non-collinear, right? Yep, contains at least 3 non-collinear points. Contains non-collinear points, and I need to name at least 3, so again I'm going to have to list A, B, and C. Excellent, and finally, postulate 10. And that says, if 2 points lie in a plane, then the line containing them lies in the plane. So I need to identify 2 points that are in a plane and show that the line going through those 2 points, line containing those 2 points, also lies in the plane. So I know I need to talk about these points A and B. It said through any 2 points in a plane. Let's see here. 2 points lie in a plane, line containing them lies in a plane. Actually, I'm going to change how I wrote that a little bit here. I have to say 2 points that are in a plane. So points A and B are in plane P. Through any 2 points lying in a plane, the line containing them also lies in the plane. So points A and B are in plane P, and the line containing them, which would be line AB, and the line containing them, which is line AB, I have to say is also in that plane. Excellent. So we did an example of all the postulates that we did not identify in the previous example. Moving on here, something else you have to be able to do today is sketch a diagram correctly using given information. So I want to sketch a diagram that shows this would be ray FH. Remember, this symbol means perpendicular to, or meeting at a right angle. This is with line segment EG at the midpoint, which is point M, of line segment EG. Alright, ray FH being perpendicular to line segment EG at perpendicular or at a right angle at the midpoint M of EG. You know what, the first thing I might do is put the midpoint M on line segment EG. So I'm going to do a line segment EG, and let's see, at the midpoint M, let's identify about where I think the midpoint is, and that's supposed to be point M. Oh, by the way, to prove that this really is the midpoint, what would that mean? It would mean that if M is the middle, EM is congruent to MG. Those line segments are congruent, and to show that, I need to mark those with the same number of tick marks. Now for sure, M is the midpoint. Now remember how it was ray FH that had to be perpendicular to or meeting at a right angle with EG? And it said they were perpendicular at the midpoint. So I need to do a perpendicular ray FH. So I'll click on my ray and make sure that I am perpendicular at the midpoint M. Now, this is ray FH. So I need to put an endpoint here. The arrow goes in that direction, so I'll put my point somewhere in here. F was the endpoint. I have to put that here. And H was out towards the ray in, what direction we're going forever. Alright, I think that's good. Showing ray FH, yep. Perpendicular to, oh, I missed something. Perpendicular to means they have to meet at a right angle, so I would have to mark that it really is a right angle here. Perpendicular to line segment EG at the midpoint, which is M of line segment EG, and I proved it was a midpoint by tick marks. So being careful drawing these diagrams, making sure you have all of the necessary marks that you possibly need to prove everything they're saying in the statement. One more sort of, it's not labeled as a postulate, but it's a really important statement here, that a line is perpendicular to a plane. If and only if, remember that if and only if means it works both ways. We could reverse the if and then, it would still work. So if and only if it is perpendicular to every line in the plane at the point it intersects the plane. Sounds really complex here. A line is perpendicular to a plane if and only if it's perpendicular to every line in the plane at the point it intersects the plane. Okay, let me decipher this for you. Look at the floor where you're sitting right now, and if you're sitting at a desk or a table, look at one of the table legs that's hitting the floor. Okay, the line would be the table leg. And more than likely, it's going perpendicular to the plane. Now remember, the plane is the floor, and maybe it's not perfectly perpendicular, but it pretend it is here. So let's say your table leg or your desk leg is perfectly perpendicular to the floor, which is your plane. And we're saying that it is perpendicular if and only if it's perpendicular to every line in that plane at the point it intersects, which means, let's say you set a ruler on the floor right where that table leg hits the floor. No matter how you would kind of spin or rotate that ruler around, as long as you're hitting the bottom of that table leg, first of all, that ruler is on the plane, it's on the floor, and it's going through that, or the point where your table leg hits at a right angle as well. So I'll try to draw a picture of this. Let's say here is my floor from a 3D sort of perspective. Okay, here's my plane, here's the floor. Now again, we're picturing like the table leg hitting at what we think is a right angle. And then if we imagine this continuing and sort of going into the plane, I'm doing dotted lines because we wouldn't see that. This is going perpendicular to plane if and only if every line that goes through this intersection would also be perpendicular. So if you lay that ruler, this green line would be like the ruler on the floor. This would form a right angle. Or let's say you spun that ruler and put it right here. As long as it still goes through this point, I know I'm a little off there, you still have a right angle. Visually it's hard to draw here. We'll talk about this one a little more in class as well. Finally, just some assumptions that you cannot assume please don't ever think that you have a right angle just because it looks like it. You'd have to see a mark. So don't say you have a right angle if you don't have the mark. If you do, obviously it is a right angle then. You can't assume that points are collinear unless there's actually a line going through them. So just because 3 points look like they're going in a straight line, you don't really know that unless they're actually all on a line. Don't ever assume that a point that maybe looks like it's in the middle, don't assume it is in the middle unless you see tick marks. On the example that we had to do our sketch, remember to make this be the midpoint, I had to know that I had tick marks here. It's only the midpoint if it divides the segment into two congruent segments and segment EM was congruent to MG. So make sure you have tick marks before you assume that you have a midpoint. And another thing, don't assume that angles are congruent unless you actually see the marks, like you see the arcs and the angles, then you can say they're congruent. So talking about some postulates today. Again, you don't need to memorize the numbers, but be able to use all of these postulates. Draw some diagrams today.